Hi girls, I have been asked a few questions about how to calculate the theoretical gradient for the swaying blade. So I thought I'll just make a little video of it so that you can watch it in your own time and hope this helps you. This is what we're doing, calculating the theoretical gradient for the swaying blade. So the first thing that you need to look for is the equation that is given in the question. So the theoretical equation is what I've got here on the top. M equals kt squared over 16 pi squared d cubed. Now what I have circled are the two variables which you're going to have on your y-axis and your x-axis. Remember, the quantity that is by itself, whatever it is what goes on the y-axis. Okay, so whatever I haven't circled in red, that means whatever is not already on the axis, that becomes your theoretical gradient. Okay, so your theoretical gradient is k over 16 pi squared d cubed. Now 16 and pi have their values, you know what they are. However, we need to know the value of k and d. So the value of k is already given. It's given as 0.35 plus or minus 0.01. And I'm just assuming, let's say you measured the length of your rod and it was 28.0 centimeters, which is 0.280 meters. And the thing is, for these numbers, all of them have to have an uncertainty. So the uncertainty for this is 1 millimeter because that was the smallest scale division, and the uncertainty for k is 0.01. Okay, so that's the first step. Now we've got to substitute these values for k and d into this equation. So here's this equation. So you've got, I've just substituted for k, which is on the top, 0.35 plus or minus 0.01 over 16 pi squared, and that's the value of d with a cube. Okay, now the rule for uncertainties is for multiplication and division, you add the percentage uncertainties. So step one, you need to convert both these absolute uncertainties to a percentage uncertainty. So when you do that, you end up with the 0.35 plus or minus, that's a percentage uncertainty for the 0.35. Now for the d, it's d cubed. So you've got to multiply the percentage uncertainty by 3 because it's cubed. So that's the working in blue over there. Okay, so take a good look. And so when you do that, you end up with the value for d, and what I've done is I've just found the cube of 0.280, so I get that number. So you end up with this. Okay, and then the next step is I'm just going to put all these together, the 0.35 over 16 pi squared times this d cubed, and I'm going to separate out the percentage uncertainties because we have to add the percentage uncertainties. So there's me. So that's these numbers, and I'm adding both the percentage uncertainties here. Okay, so when I put these numbers into my calculator for this side, I end up with 0.1009 something plus or minus 3 point, when I add both those, 3 point something percentage. I'm trying to look, it's coming as a mirror image, so I can't quite read what I've written on the screen. And then now the thing is, that is not the last step. We cannot leave the final answer as a percentage uncertainty, and the percentage uncertainty has to be got back to the absolute uncertainty. So how do I do that? So it's this 3 point whatever percentage divided by 100 times this number. So I get point, and that has to be reduced to one significant figure. So it becomes plus or minus 0.004. And the very last step is that the thing has got rubbed off. Okay, sorry, I put a paper over it. 0.101 plus or minus 0.004. So this one has got rubbed off. Okay, So that's your theoretical gradient. Now your theoretical gradient will be a little different depending on your value for D. So, but it shouldn't be too far from this. Okay, so I hope that helped. Good luck with that write-up of the swaying blade. Just keep it coming, because as I'm getting it, I'm marking it and I'm writing loads of comments because I don't know how to edit that mark sheet. But I am hoping my comments will be useful, and I'm also giving you an overall grade for it. So enjoy your weekend, take care, stay safe, and I hope you get a break as well. Okay, bye for now.